mb that is suspended from a string of length L as shown at left above. The dart is moving horizontally with speed v immediately before it strikes the block and remains embedded. The dart block system that swings up to a point at which its center of mass reaches a maximum height above the starting position, as shown right above. The block's mass mb is greater than the dart's mass md. Indicate which object the dart or the block if either experiences an impulse of larger magnitude during the collision. If the impulse is the same magnitude for both objects, state this explicitly. I'll briefly explain your reasoning.
So A, how do you answer the question? Richard, how do you answer A?
I'm not sure.
So first, when you read the question, what is given? What is given what you are looking for in this case? Over here, so this dot moves in, it's colliding the block with a certain velocity, right? Initial. And right now, you are looking for the impulse. The impulse on the dot and on the block. How do you compare? How do you compare? What are the impulse depend on? What is impulse?
Change in momentum.
Yeah, change in momentum. And then also impulse. What does impulse depend on? It's change in momentum. It depends on, remember, it's a force time delta t, right? Right?
Yeah.
So the change in momentum on the dot, the change in momentum on the block. What's the relation between these two? Basically, the change in momentum on the dot and the change in momentum on the block. What is it? Should be equal, right? Should be equal, right? Because this is the action-reaction force. The force on the dot and the block, they should be equal and opposite. Do you see that? Right? Should be equal and opposite, right? So in this case, you can say that the magnitude is the same. The magnitude is the same. You can explain this question in terms of two ways. One way, you can say that it's both the dot and the block experience the same equal and opposite force because of Newton's third law. Write it down. Newton's third law, okay? So the force exerted on each other, they are equal and opposite. The second way to explain this question, you just choose one of them. Okay, you don't need to say both. By conservation of momentum, right? The decrease in the momentum of the dot must be equal and opposite to the increase in the momentum of the block because of momentum conservation, right? So the impulse will be same magnitude. So the second one, you use momentum conservation to answer it. You got it? Okay, B. Brandon, you can read a B.
If the
Reading this
speed of
part.
the yeah, if the speed of the dart as it embeds itself into the block is greater than v, how would the maximum height reached by the center of mass of the dart block system compare to h? Explain your response without deriving or manipulating equations. Two students are discussing the motion of a dart block system at the instant it reaches height h. The students make the following statements. Student 1. The speed of the system at height h is 0. Since it is moving in circular motion and centripetal acceleration is given by ac equals v squared over r, the acceleration must also be 0. Student 2. The acceleration of the system at height h can't be 0, or the system would not swing back down. The acceleration must be equal to g at height h.
Thank you. So B, how do you answer it? So B, how do you answer it?
Is it student 2?
Didn't you? Putting B, B, how do you answer this question? How would the maximum height change compared to H? Does it go higher or lower or same? Greater, less than?
Um, Higher,
Higher, okay. Why?
because 1/2 md plus mb v squared equals MD plus MB H, and 1/2 V squared equals GH, and yeah, I'm not sure. I just thought it was higher.
Higher, that's correct. How about Brandon? What do you think?
I think higher, but I'm not too sure how to explain it.
So the speed of the dot is greater than V. How would the maximum height reached by the center of mass of the dot block system compared to H? It will be higher. Why? Because the momentum of the dot will be higher if you increase your V, right? So the momentum of the dot before collision must be equal to momentum of the dot block system after collision. A higher dot speed will give the higher dot block speed after collision. So higher speed, it will have a higher kinetic energy, which means that this higher kinetic energy will be converted into potential energy. Like Richard, you are using the equation, that's fine too. Sometimes if you don't know how to explain, you can use the equation to help you explain. Just don't leave anything empty, right? You good? So B, you know how to answer it, right?
Yeah.
Okay. Now, C, D, E, F, you can see it's about student 1 and 2 statement. Which one is correct? Which one is incorrect? Or both correct, both incorrect? What do you think? So you can tell me right now. Brandon, student 1, which statement is correct?
Um,
Mm-hmm.
the speed of the system at height h is 0,
Yeah. So
but
3
then
is 0. That's correct. Okay.
but then the
And then
when it says the
acceleration. How
acceleration
about
must also be 0, that's incorrect, right?
that's incorrect. Okay. Thank you. Yeah. Now, how about student 2, Richard?
Um, right. The acceleration must be equal to G at height. Wait, no.
Mm-hmm.
I think they're correct.
Well,
No.
they are both correct. Acceleration of the system at high h cannot be 0. That's correct, right? It's not
Yeah.
equal to 0. Okay.
Yeah.
Now, is it equal to G? Is it equal to G? No, it's
Oh,
incorrect too, right? Does it make sense?
yeah.
Right? It's not equal to G because in this case, the net force is the vector sum of tension and mg. You got it?
Yeah.
Does it make sense? You good? Okay. And then now let's look at G. G, Brandon.
Oh, you want me to read it?
Yeah.
The students correctly derive an equation for the maximum height. H equals 1 over 2g times mdv over md plus mb squared. Explain how this equation supports your claim in part B.
So how do you answer G? Based on what we talked about, and then you just need to use the equation to explain. I attached the file in the chat box. You can download it if you need. I mean, last time did I give you this file? So explain how these equations support your claim in Part B. Region.
Um,
Mm-hmm.
is yeah, I'm not too sure what MPV over MD plus MB is for.
Oh, you don't need to worry about if this equation is correct or not. You just need to use this equation related to your claim in Part B. Part B, what conclusion did you make? What claim do you have for Part B?
It's higher.
Yeah, it's higher. So according to the equation, if you increase the V, is H higher?
Yeah.
Yeah, then you just answer the question like that. Does it make sense?
Yeah.
So you just need to say that, oh, according to the equation, V is in the numerator. When V increase, your H also increase. That's why it's supporting your claim in Part B. Does it make sense? You don't really need to check if the equation is correct or not. You just need to use that variable you are talking about in Part B. You don't need to check, oh, if this equation, how to derive it. But this part, I can show you how to derive it. You understand how to derive it?
Not really. I'm not sure how like the V turned into that.
Okay, now you need to make sure, take a note, huh? Pay attention right now, because this is a common question you will see. So earlier in Part B, you already mentioned you are going to use the momentum conservation. That's the collision when the dot connect with the box, right? Brandon, are you taking notes?
Yeah.
So when the dot connect with the block, momentum is conserved. So you write down it will be MD times V initial will be equal to MD plus MB time V final. Okay? That's the momentum conservation. And then you will find that V final will be equal to MD V over M dot plus M block. Right? In outer collision, they move together. And you use energy conservation. So initial energy equals the final energy, which is half MD plus MB. Don't forget, these are outer collision, not before collision. The kinetic energy is the energy outer collision. Not before collision, right? So it'll be V final square will be equal to MD plus MB GH. You see that? And then these cancel out, right? Same math. So you'll find H will be equal to V final square over 2G. Then you plug in V final square. So it will be MD V over MD plus MB square. That's how you derive it. This question didn't ask you to derive it, right? But sometimes the question will ask you to derive. You got it?
Wait, I'm not done. Yeah, I got it.
Got it? Brandon, are you done?
Yeah, I just finished.
Finished? Okay, Brandon, you can read this part.
The students perform several experimental trials. Each trial, a different speed v is used, and the resulting maximum height reached by the center of mass of the dart block system is measured. H. Which quantities could the students grasp to produce a straight line whose slope can be used to find the acceleration due to gravity g? After the collision, the dart block system is then allowed to swing freely, and the students produce the graph shown below at left, labeled Group 1, of the vertical position of the center of mass of the dart block system as a function of time. A second group of students makes a single change to the setup and then repeats the experiment. Their graph labeled Group 2 of the vertical position of the center of mass of the dart block system as a function of time is shown below at right.
So how do you answer this question? So H, we mark there, like I mark there, oh, you are going to measure speed and maximum height. What quantity you can graph to produce a straight line? What quantity? Richer.
Um,
You want to get a straight line.
yeah.
Does it make sense?
V squared.
V square on x-axis or y-axis? What is it?
Um, V
Mm,
X-axis?
okay, v square on x-axis. Then what is on y-axis? V square is not enough. You need to say
Like
oh,
H?
h on the y-axis. Okay, yeah. So you just you need to mention that which quantities? Height and v square.
Yeah.
Why do you pick height and h square? V square.
Um, actually, I'm not sure. Our teacher went through it like in class, but like I don't know.
Oh, because you are measure v, you are measure height, right? And then you look at this equation. This is h equals 1 over 2g md over md plus mb squared times v squared. In order for you to get a straight line, you need to get y equals mx plus b, right? But this is v squared. If you plot h versus v, you won't get a straight line. That's why you want to use h versus v squared. Does it make sense? Brandon, right?
Yeah.
Does it make sense? Richard? Richard got it, right?
Yeah.
Mm. Right. So just remember anytime it asks you to draw a graph, you have to make sure you know what you are measuring first, and then you know the mathematical equation, or else you cannot tell. Okay? You have to know the mathematical equation. That's why. You done? You done, right?
Yeah.
Yeah. Then Richard, you can read the last part.
After the collision, the dot block system is then allowed to spring freely, and the student produces the graph shown below at left labeled group 1 of the vertical position at the center of mass of the dot block system as the function of time. A second group of students make a single change to the setup and then repeats the experiment. The graph labeled group 2 of the vertical position at the center of mass of the dot block system as a function of time is shown below at right.
Mm.
Indicate the single difference in either the dart mass, initial dart speed, block mass, or string length between group 1 setup and group 2 setup that could lead to the difference between the graphs.
Mm. So what do you think? Indicate a single difference. What's the difference between these two graphs?
Period.
Period. Which period is bigger?
Group 1.
Group 1 is bigger. Group 2 has a shorter period, right? Then indicate what can be changed. Could lead to the difference. What can be the difference? What can be the difference? What can be the difference? How do you change the period? What does the period depend on? Or the question can be asked in different in this way. So how do you change the period in this case? So when we talk about simple harmonic motion, there are two types of situation. One is a spring mass, the other is a pendulum, right? Spring mass, what does the period depend on? T equals 2 pi square root of m over k. For the pendulum, what's the equation to find the period? Brandon.
I forgot.
Richer.
Oh, is it 2 pi square root of L over G?
Yes. Very good. So 2 pi square of L over G, right? Then right now, you can see group 2 has a smaller period. What can you change? What can you change?
The string length?
Yeah, make it shorter or make it longer. Make it shorter or longer. In group 2, is it shorter? Is it the length? This will be shorter, right? Right? This will be shortened, right? Shorten the length, right? So it says that indicate a single difference. The single difference will be, or group 2 must be a shortened length, shorter length, right? Group 1, the length of the string must be longer. Does it make sense? Does it make sense? Okay. Good. So now let's do another question about the spring situation. So look at this one. Look at this one. Brenda, you can read the question.
Block 1 is at rest on a horizontal surface and is connected to a wall by an ideal spring. Friction between block 1 and the surface is negligible. Block 1 is held at rest at point A to the left of point B, which is the equilibrium position of the spring block system as shown in the figure. Block 1 is then released and allowed to oscillate. Sometime later, block 1 is momentarily at rest at point C. Consider the positive horizontal direction to be towards the right. A. The dot below represents block 1 just after it is released. On the dot, draw an arrow indicating the direction of the net force exerted on the block just after it is released. The arrow should start on and point away from the dot.
So over here, how do you draw the force? Net force exerted on the block. Now, so what is it? How many net force? How many forces given this net force? Right? Remember, you are drawing net force. It's not free body diagram. Richard, how many net force apply on the block?
I'm not really sure what it gets, but like it's saying it's not free body diagram, it's just net force.
Oh, so the question tell you when you are at point B, that's a unstretched length, right? Does it tell you?
Yeah,
B is equilibrium is unstretched length. So like right now, your spring is compressed when you are basically the block is held at rest at point A. So in this case, the spring is compressed, right? And what's the direction of force applied on the block? Because remember, this spring force is a restoring force, right? When
right,
you
so
are
it's
here, going,
negative.
and then when you are here, the force is going this way, that's the spring force, right?
Yeah,
So when your hand, you release it, so your hand, the force you apply, external force will be gone. The only force, the net force applied to the block, what is it?
uh, just FG.
Fg and Fn will cancel out each other, right?
Yeah,
Yeah, so in this case, what kind of situation? So the net force will be going to the right, right?
yeah,
Does it make sense? Brandon?
Yeah, it does.
Okay. So it will be going to the right, right? You understand why is it going to the right? Hmm. Done, right? So the net force will be going to the right. Basically, that's a restoring force applied to the block, right? Okay. Now, you read this part? Richard, you read it?
after the block has been oscillating on the table, a motion detector is turned. The motion detector is turned on and the velocity block one as the function of time is measured and plotted in a graph. The student correctly draws a best fit curve that represents the oh,
So over here, this graph, what do you see? When t equals 0, v is a negative maximum, right? Right? So you go from A, B, C. So when t equals 0, the velocity is a negative maximum. Why do I point it out again? So make sure you remember what's on the graph, right? Now B, continue to read it. Richard, you can continue.
a student looking at the graph of velocity as a function of time makes the following claim. A motion detector was turned on when the block is at point A and moving to the left. Does the data in the graph support the student's claim about the location and the direction of the block's motion when the motion sensor is just turned on? For incorrect claims, if any, state the correct position or direction of the motion. Justify.
Mm-hmm. So B, how do you answer it? Does the data in the graph support the student's claim about the location and the direction of motion? when the motion sensor was turned on, right? And remember, pay attention to what it's asking, right? Sometimes you guys will miss 1 point because you didn't answer one on the small question. Right, so for any incorrect claims, if any stay in the correct position or direction, justify your answer. So look at the graph here. The graph here, do you see that? So B, how do you answer it, Brandon? Mm-hmm.
Oh, I'm just thinking right now.
Mm. Richard, what do you think?
Uh, I'm not sure.
Mm? So over here it says that the student look at the graph, this graph of velocity as a function of time. Made the following graph. The motion sensor was turned on when the block was at point A and was moving to the left. Eh, do you think this when t equals 0, the velocity is negative maximum is at point A? What do you think? Is it point A? At point A, when it's released, V will be 0. So cannot be point A, right? In this case, you see that velocity will be negative maximum. So what point it can be when you have negative velocity? Negative maximum, where? It will be at point B, not point A. Remember at equilibrium, write it down. Always at equilibrium, that's when you have maximum speed. It's a negative. Why is it negative? Because it's going to the left, right? Oh, it is negative. So going to the left, that's correct. In the claim, right? Claim says that moving to the right, to the left is correct. But the point at A is wrong. It should be point B. That's where your V is maximum. Does it make sense? You got it? Richard, you got it?
Yeah.
Brenda, you got it?
Yeah.
Mm. Okay, now you can read C, Brendan.
Block 1 is stopped, and again block 1 is held at rest at point A. A second identical block, block 2, is placed at point B. Block 1 is released from rest, and then collides with and sticks to block 2. After the collision, the two blocks oscillate together on the spring. On the graph below, sketch a curve to indicate the new velocity as a function of time of the two blocks after the collision. For reference, the dashed curve represents the student's best fit curve of the velocity as the function of time, described in part B.
Right? So what do you think? Try to see what kind of problem. So, Richard, what do you think? What do you think?
I think the amplitude might be like a little bit smaller.
What's smaller?
Amplitude.
Amplitude. So it means that outer collision, right? The velocity
Yeah.
is smaller. Good. Why? Why?
Um,
Why? Why is it smaller?
because there's more mass.
More mass. More mass. This is outer collision, right?
Yeah.
More outer collision, more mass. So your velocity is smaller, right? Okay. Then what other change? What other change? Brandon, what other change? Do you also agree velocity will be smaller? Mm. What other change you can see? Remember on the y-axis is the velocity. Velocity is smaller. Does the time change? Or does the period change? Richard, think a little bit more. Think deeper. Does the period change? Mm. Richard,
I think so.
why?
Period is
What does the period depend on?
like root k over m.
Or root 2 pi is
Right, root
m
k.
over k.
Oh,
Remember,
m
it's
over
not
k.
k over m, right?
Oh, okay.
Main killer, m over k. Sometimes you will plug in the wrong equation and you will get totally wrong answer. So be careful, right? So what happened? Mass increase, right? That's why period increase. So over here, you will see that, oh, V decrease and then the period increase. So you need to draw a wider and lower amplitude. Why is it lower amplitude? Momentum conservation, right? Make sure you write it down. Brenda, are you there?
Yeah, I'm writing it down right now.
Mm-hmm. You understand why V is getting smaller, right?
Yeah, I get it.
Because of momentum conservation. After it collide, what happen is your mass outer collision is perfectly inelastic. They stick together, they move together, mass increase, right? That's why the V final is smaller. You got it? You got it, right? Mm. Okay. So let's talk about more questions right now. Do you need a break? Let's take a 5 minutes break. If you need to use the restroom, go right